student volunteer Haris Momtaz, and I'm very grateful for him to be here. And let me make sure, yes, getting lots of notifications from Midspace. So let me just go through what we're going to be doing. This is going to be a rather busy session. We have 6 papers lined up. We are going to be presenting these back to back as you have seen in the instructions. Each paper will have 5 minutes. Please try to keep your presentation within 5 minutes max. After the presentations, we're going to be having a discussion session, and at that point the audience can ask questions from the speakers, and it's also highly encouraged for the speakers to ask questions from one another. And for the question period, anybody who has questions, please feel free to put your question in the chat. Otherwise, say that you have a question for a certain speaker, and then when we get to that, you can simply unmute yourself and ask your question if that is more convenient. And yeah, just make sure that you, for the question and answer period, you put the name of the person you're directing the question to at the beginning, so that it's going to make the life a little bit easier. Perfect. So with that said, and without further ado, we are going to start our presentations. The first 5 presentations that we have are from the SEEP track, and the last one is from the technical track. So we go to Tim Hubener, who is going to be presenting a paper titled Automatic Anti-Pattern Detection in Microservice Architectures Based on Distributed Tracing. So Tim, the floor is yours.
Okay, thank you very much. So I'll first share my screen. And I think it should be working, right?
Absolutely, please go ahead.
Great, okay. So hi everyone, my name is Tim and I welcome you to this presentation on automatic anti-pattern detection in microservice architectures based on distributed tracing. So just to get everybody on the same page with the microservice architecture, we define the idea of the microservice architectural style as to develop a single application as a suite of small components called microservices. So in this slide, we have a single application with the 4 services on the right side. This architectural style has enabled large companies to scale the development of their applications as teams can work a lot more independently from each other. But the question is, how can we ensure that the architectural quality is not neglected during development? Because the teams, the code, and the decision processes are highly distributed throughout the company, and teams usually only focus on the services they rely on and the services that rely on them. So it is very difficult for a single person to have a holistic overview of the entire application and detect any emerging anti-patterns. So we define the research question as follows. Can anti-patterns in microservice architecture be automatically identified from distributed tracing? And we were motivated here by improving the quality of microservice architectures, making it easier to identify anti-patterns in large applications. With 4 services, as we've just seen in the previous slide, it is easy, but if we go to 400 and more, it becomes a challenge. And we want to prevent biases when evaluating the architecture. So now let's look at the results from our case study at ING. Here on the right, we can see a visualization of most of the services at ING. Collecting this data was the first challenge we had to overcome. Since the code artifacts are distributed across the company, we could not fall back on static analysis or repository mining. This is why we used the distributed tracing to collect the data. On the collected data, we used our methodology to detect the anti-patterns. And in our methodology, we first characterized the anti-patterns we wanted to detect. And we did this by defining a vector for each anti-pattern based on service-based maintainability metrics and graph theory-based metrics. Next, we computed a vector with the same metrics for all services from the data recollection step. And finally, we compute the vector distance between the anti-pattern vector and the service vector. This resulted in a list of services that expressed anti-pattern characteristics. However, this was very abstract, and therefore developers did not engage with the results. So therefore, we wanted to visualize our findings to make the results more tangible for developers. And visualizing large graphs is a challenge by itself, but the results from the anti-pattern detection allowed us to use some tactics to improve the visualization. So detecting the anti-patterns beforehand means we can use that information to make the visualization more informative. And now here, in this large graph, we can highlight the 5 largest mega services within the context of the entire architecture. However, we're also able to filter on services, and here we filtered on services that have a cyclic dependency on each other, or a cyclic dependency with n different services. Additionally, we can add live information from the distributed tracing data to basically confirm or disprove any anti-patterns that were detected. In this case, we found a service that was a bottleneck and it had a bad throughput rate. So to conclude, yes, we were able to detect anti-patterns and the visualization was a valuable tool, but the results need to be verified by a domain expert. Not everything that was flagged as an anti-pattern was actually an anti-pattern, and some anti-patterns might not always be necessarily bad. So in the future, or in future work, we want to do an in-depth validation of the detected anti-patterns. Now we could only do a sample. We want to improve the linking of service metrics to anti-patterns. We want to measure the metrics over an extended period of time and add more context data points. Thank you very much for your attention.
Thank you very much, Tim, for the great presentation. So we are going to move on to our second presentation now. This is going to be presented by Breno de França, and the title of the work is Organizational Culture and its Impact on the BizDev Interface. Breno, please go ahead.
Okay, just sharing here. Thanks for the introduction. This work is related to the concept of BizDev interface. The BizDev interface is kind of similar to what we know regarding DevOps, but the collaboration target is more to the upstream of the value chain that is related to business strategy and development areas collaborating to achieve continuous and healthier delivery of products. The case we investigated is a company that is a global leader in the market of mobile apps for kids for entertainment. And the company has about 5 years with 3 main products. One of them was under investigation. And we interviewed 15 people from both business and IT sectors. And the IT sector's profile related to mobile development, back-end and full-stack development, and some people from design, actually. From the business sector, we interviewed people from the product management, content management as an application for kids. It has some books, some videos, movies, some series that are offered inside the platform, and also people from growth that are understand how the products, basically the product roadmap. We did a 2-phase interview. It was almost 1 year because we interviewed some parts of the participants, and we analyzed it in full using Gradient theory, as I will explain it later. And then we had another round of the interviews, and then we analyzed it later. The main phenomenon that we discovered in this case was that interesting people from the IT sector was acting in business or doing business activities. So they were working, for example, in prioritization of requirements. They were defining features or requirements for the products. and they showed a data-driven behavior, that is, they were collecting data from production environments to extract metrics and business metrics and indicators, and trying to make some benchmarking with competitors to understand what could be improved in existing features, and which ones could be the new features. And the idea of proposing new features for the product, they actually start proposing new products for the company. So one of the major drivers for this kind of behavior was actually attributed to the organizational culture. So the organizational culture was influencing how people of the technology teams was acting business based on the values that were actually strongly present in the daily routines of the employees. So one of the values, for example, is the sense of ownership, and the people from development teams were, how can I say, motivated to try to make some impact on the business, so they can see their work reflecting on the main products of the company, and achieving new customers. And so they were kind of motivated to do that. So these kind of values and principles that the company had, and also the open environments for the receiving suggestion and questioning the work from and to the business, facilitate the idea, make easier the idea of contributing to business with the perspective of a development team. However, we also observed that some of these attempts to impact the business had some issues, and mainly these issues were raised based on the lack of alignment between business and development teams. So when this actuation was not properly aligned between business and development, some of the features didn't succeed, and it kind of harmed some aspects of the business inside the product. And also we understood by the data collected with the interviews that the culture influenced this kind of lack of alignment too. So in part it has a positive effect, and in part it has a negative effect. That is, the urge to create things and to impact the business also make things to go out of pace. So some ideas of features, some features that were idealized by the technology teams, also did not have the better way to deliver these features, because they didn't align it very well with the business. So they lose some perspective on the business side regarding how to make a better presentation, or a better how they could better sell this feature. So this main phenomenon that is related to how people in the development teams are acting in business activities, we stressed the organizational culture as the main motivation factor. The behavior that is strongly stimulated and present regarding data-driven. So in order to convince the people from business strategy, they need to bring data from production, collect data with analytics, and try to convince that the idea was feasible. So it has positive results and some kind of lack of alignment. As a main outcome of this research, we understand that is a challenge for the industry to try to understand how can organizational culture can motivate people to act in business, but in a safe way, without harming the business actually. So this is it.
Thank you very much, Bruno, for the excellent presentation. Moving on to our third presentation. This is a paper titled "A Software Impact Analysis Tool Based on Change History Learning and Its Evaluation," presented by Yoshi Nakajima. Yoshi, please go ahead. Yoshi, are you there? Okay, if Yoshi is not there, then we will perhaps move on to the next one. Let's just give it a few more seconds. Let me check if Yoshi... Yeah, Yoshi has been having issues with his connection, and we were trying to troubleshoot that before the session, but unfortunately, things did not apparently work. Okay, so in the interest of time, let's move on to the next presentation. If Yoshi joins later, we are going to fit him in. So we have our fourth paper titled Looking for Lacunae in Bitcoin Core's Fuzzing Efforts. And this is going to be presented by Alex Gross. Alex, please go ahead.
Second to start audio. Can you hear me?
Yes, please.
Okay. So this paper is looking for lacunae in lacunae, I think is how to pronounce it. We were actually discussing that before the session started. I actually realized where I wrote this, but I didn't actually think through how to pronounce it. But this paper is on an effort actually where Chaincode Labs, who is sort of the R&D arm of the Bitcoin Core main implementation, sort of the canonical implementation of Bitcoin, contacted, actually, they saw a blog post by myself and John Reger on what's called saturation in fuzzing, which essentially amounts to we're fuzzing, we've been fuzzing, but we're not seeing new bugs, we're not getting new coverage, we're sort of stuck. What do we do about this? So they wrote me asking, you know, do you have like a student who's not too busy who could help us out? And I said, well, I don't really have a student who could do this, but I'd really like to do this. So I talked to them, and it ended up being an effort to look into their fuzzing process. And actually, in a 5-minute talk, I'm going to give the short summary, which is they're doing a pretty good job of fuzzing, actually. They're using some of the new stuff that's been added to LibFuzzer that sort of gives you a nice interface to sort of access data types of various kinds. They've improved this a little bit themselves. They've got a nice set of a huge, actually, array of fuzz drivers for different parts of the code. They're getting a lot of coverage out of this. And in some sense, they were saturated, actually, because as far as code coverage goes, on the very critical parts of the code, like transaction verification, which we looked at, and I'll show you this in a second, a graphic related to this. They're actually at like 98 point something % coverage. There really isn't a lot to do, and probably what's left is very hard to cover code. Now, one thing that I ended up doing is, in addition to trying to apply a number of different additional fuzzers beyond what they had used AFL and LibFuzzer and hadn't really used AFL very much. I looked at mutation testing. So I actually compared, and this bizarre sort of Mauve Cthulhu graphic is the mutation kills for the 400 and something mutants of the core transaction verification code, txverify.cpp. So the functional test for Bitcoin and the fuzzing actually both achieve about 98.5% coverage, call it. And it's slightly different coverage, actually. The things that are missed are different in the two systems. But the upshot is that the mutation kills are really good for the functional tests. Really good. So 278 mutants are killed only by the functional test. There are some additional ones here you can see that are also killed by the fuzzing. So the only things that fuzzing kills actually are 2 unique mutants and then a bunch shared with the functional test. So from this graph, you might actually think, well, the fuzzing, maybe the coverage is good, but it's actually doing a poor job of actually testing anything. So that's actually, I think, not the case. There are quite a few bugs they're finding now that they're running this through OSS fuzz using just the fuzzing. And they're not found by the functional test. And you can sort of see that these 2 bugs are doing something that is very odd that the functional tests don't do, which is actually analyzing things with a block height of 0, which isn't really realistic, but it exposes potential issues in back end of how to handle data when there's sort of unusual data. And I think that's the kind of thing fuzzing is finding. So traditional code coverage isn't going to show you what's strong about the fuzzing necessarily. In something like this, where people actually, unsurprisingly, devote a lot of effort to getting good coverage on, the core test for Bitcoin's main implementation. It's not like this is some 50%, covered throwaway project where fuzzing is going to give a huge gain there. What it's doing is it's covering very subtle data impacts and unusual inputs. But what this also shows is that really the best way in an effort like this to improve the fuzzing is almost certainly to improve the invariance and assertions in the Bitcoin core code itself. So I think the biggest upshot for a 5-minute talk of our work is I tried a lot of things and then talked with my co-authors who I should have mentioned, which is Kush Jain and Claire Legou at Carnegie Mellon and Reinhard van Tonder at SourceGraph, and then Gautam, my graduate student at NAU. But what it really looks like to me is that they need more assertions. The assertion density in this code for how critical this code is fairly low. It's certainly way below like recommendations like at JPL, we suggested like 2 assertions per important function in the code. And it's just way below that. And I really think improving the power of Bitcoin itself to notice when invariants have been violated is what really would get their fuzzing up. I think the fuzzing is exploring a lot of weird paths through the important code. What's happening is that there are things that are happening clearly that are covered in both, and the functional test noticed this did not do what it's supposed to. The fuzzing can't see that because it doesn't have that mapping. Now, you can't do the same kind of checking. You don't have a simple input-output, but I really think that Bitcoin Core could boost the effectiveness of the fuzzing best in this case by actually improving the power of the invariants and oracles in the code itself. And if you're interested in this, there's a 2-page paper in the proceedings, but it also links to this full report, which gives a lot more detail on everything we tried and sort of more detail on actually how Bitcoin fuzzes things for one point, but also the things that were tried that didn't add a huge amount here, although they added actually a few thousand new corpus tests. And probably in the long run, those were helpful in finding some more things. And I think that's my 5 minutes.
Thank you very much, Alex. So let's see if Yoshi is back by any chance. I think I saw him in. Oh, Yoshi, are you there?
Yes.
Excellent.
Can you hear me?
Yes, yes. Please go ahead and share your screen.
Okay.
So let me just reintroduce the paper. This is the 3rd paper originally in the track. And it's entitled A Software Impact Analysis Tool Based on Change History Learning and Its Evaluation. And it's going to be presented by Yoshi Nakajima.
Oh,
Yoshi, please.
yes.
Alex, can you stop sharing the screen? Excellent. Okay, so Yoshi, can you go ahead and share now and see what happens? Something is coming up. Awesome. Okay, please go ahead. I think we're all set.
Okay. So can you hear me?
Yes.
So sorry about my trouble. Hello, everyone. I'm Tsuyoshi Nakajima, Shibata Institute of Technology, Japan. Today, I will talk about software impact analysis tool based on change history learning and its evaluation. First, I would like to talk about software change impact analysis plays an important role in controlling software evolution, especially for many projects working on the same large source code base. The key importance for the analysis is to improve accuracy and efficiency in creating modification candidate without depending on developers' knowledge. The target projects are software development of continuously evolving products working on one large source code base. About 30 projects run every year. Each project has 10 change requests on average. So approximately 300 change requests are generated every year. The problem is that many small projects run in parallel with shortage of human resources. The target project strictly follows the rule that one change design document, including requirements and the changes on source code, is created for every change request. The number of components in the source code base is 32. Over 1,000 documents have been accumulated. This slide shows our approach. We develop a tool to machine learn many change design documents to infer modification candidates to a new change request. This figure shows the configuration of the machine learning components in a tool. The tool firstly extracts the text of the change request written in Japanese from the change design document and translate the text into a vector tone using word embedding technique. Secondly, it extracts modified components name and then convert them into a components component vector. Each element of the vector is 1 when the component is modified, or 0 otherwise. Since the component vector has multiple levels to be classified, this machine learning is categorized as a multi-level classification. For the multi-level classification, metrics for evaluating single-level classification, such as accuracy, recall, and precision, cannot be simply applied. So we introduced 2 new metrics: cover ratio RC, accuracy in the coverage range AC. I'll skip their explanations. Part of the experiment shows very high performances. We did the experiment to evaluate our tool. The figure shows the data size used for the experiment. 405 change design documents are used in total. 325 for training data and 80 for test data. The result of the experiment shows very high performance. The average ratio here and here and here, less than 20% for all the implementation of the vectorization. This means that the modification target can be by level.
Yoshi, sorry for interrupting.
Candidates on average.
Maybe it's just me, but we cannot
in addition,
see
the
anymore.
accuracy in the coverage range exceeds 50%. That means that more than half of the reviewers can find modification targets. The result indicates significantly reduce the workload of impact analysis. Let me conclude this presentation. I proposed and we propose and implement impact analysis tool that machine learn histories. We use the tool and experiment using real project data. So effectiveness of the proposed tool. Future issues listed here. Thank you for listening.
Thank you very much, Yoshi. I think for a little part of your presentation, we might have lost the screen share, but we could hear you all along. Thank you very much. So moving on to our next paper. This is a paper titled Transition-Based Parsing of Release Notes for Intelligent Code Updates. And this is going to be presented by Petr Babkin. Petr, there was a discrepancy on the website in terms of the title. If it's AI for, AI for intelligent code updates, please use that title, but I saw this discrepancy and brought it to the attention of the chairs. I don't know if it was fixed, but please go ahead. Yeah, so this is the true title, AI for, okay. You are on, Pet, we cannot hear you. We can see your screen, we cannot hear you.
Hello?
Hi, we can hear you now. Please go ahead.
Okay, great. So this is joint work with Salva Elamir, Nacho Navarro, and Simina Shah. In this presentation, I'm going to give a brief overview of the problem we're trying to solve, the approach, and some of the results. I invite everybody to check out our full talk for all the details. So the problem we're trying to solve is to try and parse a library deprecation usages, ones that you might find in release notes of popular libraries. Over time, libraries get updated and they have improved and added functionality. Also, some old functionality gets decommissioned, but before it's fully removed from the library, there's deprecation messages that get inserted so that whenever a old API usage gets used, there's a message that pops up prompting the developers to update their usage because the functionality is going away. So far, there's not an automated way of automatically update the client code that uses this outdated functionality. So this was the motivation that came from an internal use case in our firm. How can we leverage the open source library documentation to automatically parse up those documentation texts and devise an automated way of updating code without human intervention? So the input to our model or to our system is a collection of deprecation texts, such as the one shown here. So this comes from a release notes webpage of a library called Pandas. And this particular example tells us that the keywords, levels, and codes should no longer be used in the method copy of the class multi-index, and that two new methods should be used for each of those keywords respectively. So levels should be used with set levels and codes should be used with set codes. And we formulate the problem as that of semantic parsing, meaning that as the output from our model, we want to get a structured representation, a tree representation that specify exactly what code is deprecated and what should be the replacement. And here's the example output for this particular text. And as you can see, there are some non-trivial transformations happened in the tree because you can see that the keywords get duplicated. So some of the things that are implicit in the text, they have to be made explicit in the tree so that we have one-to-one correspondence between each unit that get deprecated, keywords in this case, with each new replacement code. And after some analysis of a sample of deprecations, we have come up with basically context-free grammar to which most of the deprecations abide. So basically, at the high level, we have a deprecation subtree and optionally a replacement subtree. And the deprecation subtree could be made of a namespace, such as, in this case, multi-index class name. And then under that, we could have a function, an attribute, such as a field. And under functions, we can have arguments. And this is proven to be pretty generalizable. most of the deprecations have fallen under this pattern. So now that we have a problem formulation, how do we tackle this approach? We take the transition-based parsing approach, where transitions, I don't know if you're familiar with, for example, shift-reduce, but it's an approach based on iteratively applying some operations that modify the parse tree and some data structures that contain temporary results. And there's a number of parser actions or transitions defined. And this way we can iteratively apply each of those transitions, gradually building up a tree. Like in this example, here's a complete derivation. And at the very bottom, you can see that we got to this resulting tree using this sequence of transitions that we've applied. To basically make this model work at sort of in runtime, we combine it with a classifier, which basically takes in some features about the input, such as their syntactic features, and makes a multi-class classification. It tries to pick an action that should be applied to the parse tree. And then this action gets applied. A new parser states result from that action, and then the parsing action, the new parsing action is picked until the tree is fully produced. For evaluation, we manually annotated over 400 different deprecations. We've annotated what was the old code and what was the new code, and then we used the Python's AST library to automatically convert those code elements into trees. And then for our evaluation, we used a simple baseline that simply splits the text on the word deprecated, grabs all the code elements before that as deprecated code elements, code usages, and puts all of the code elements that follow the word deprecated as updated usages. Whereas for our parser, we first convert the code as a tree into a tree, like I mentioned, and then we compute a tree overlap based on a recursive formula where we break up a pair of trees into their corresponding subtrees, and then at each level we keep comparing the trees until they're equal, and then we basically sum this up in a weighted fashion to compute a notion of precision, a version of precision and recall on that tree. So in this table, and this is the last slide, we have evaluation results of our parser-based model with a simple deterministic baseline. We have the mean score and also break down across different deprecation types, for example, methods, parameters, namespaces, and such, as well as different libraries. So the main takeaway is that we have significantly outperformed the baseline, not only on average, but also in method deprecations and specifically in parameter deprecations, because correctly parsing parameter deprecations requires a notion of compositionality, which the baseline, of course, doesn't have. Whereas the parser is capable of capturing compositionality by putting arguments together with method names. And speaking of different libraries, Pandas library is by far the easiest to parse, and which we've observed also subjectively while annotating the data. We've observed that the deprecations are more straightforward and they follow a similar format, as opposed to something like matplotlib deprecations, which are really hard to comprehend even for humans. All in all, this remains a hard task, and hopefully this research opened up avenues for future inquiry into advancing the state of the art in this problem. Thank you.
Thank you very much, Petr, for the excellent presentation. And we are moving on to our final presentation in this session, titled MOREST, Model-Based RESTful API Testing with Execution Feedback, presented by Yi Liu. Yi, please go ahead.
Okay, so can you see my screen?
Yes.
Okay, so hello everyone, I'm Yi Liu from Nanyang Technological University, and I'm going to present our work about RESTful API testing. This work is collaborated with our industry partner Huawei. So cloud computing plays an important role in current cloud platforms. Therefore, the robustness of cloud computing services is critical. Bugs may lead to cyber attacks which cause financial losses. So first of all, let me introduce what is a RESTful API. A RESTful API means a constraint of REST style. So currently, RESTful APIs are widely used in cloud services. One of the challenges in RESTful APIs testing is how to infer API calling sequences from OpenAPI specifications. For example, how can we get those calling sequences from its specification? So we proposed a solution named RPG based on the property graph. We encode schema and operations into it. So this figure shows a detailed workflow of Morist. To test a RESTful service, Morist first takes its OpenAPI specifications as input to build the RPG. After building the initial RPG, Morist uses it to generate call sequences and replace the API calls in the calling sequences with actual requests. Then the generated test cases are fed into the target RESTful API service, and Morist shall collect the responses. By analyzing the collected responses, Morist reports the detected failures for bug analysis. Moreover, Morist also uses responses to refine the RPG by adding missing edges and visible edges. The refined RPG is then used for generating more test sequences. So with the OpenAPI specification, Morist can build the initial RPG with nodes and edges from the properties and the labels, which may contain false edges or missing some edges. So here we introduce how Morist used to generate test case. In general, this requires two steps. First, Morist traverses the RPG and aggregate visited operations to generate call sequences. Second, Morist generates concrete input for the API in the sequences to build test cases. We generate parameters on the fly by 3 ways. The initial RPG generated from the OpenAPI specifications may contain errors, so new edges are added to our RPG when we find new dependencies. As for the edge deletion, this operation is recognized as infeasible after several tries. So we aim to answer the following research questions with the evaluation. First, it is about code coverage and bug detection. And finally, we want to study how do different components affect the performance of Morist. So benchmark contains 6 services from previous work. And we use 3 black box RESTful service testing techniques as baseline to study the performance of Morist. So Morist achieves better code coverage and robustness in most cases. Besides, Morist achieves the best performance in bug detection. And finally, RPG and dynamic updating enhance the and coverage of testing generation. So let's come to the summary. We propose a Morist, a model-based black box RESTful API testing techniques. And Morist learns from the OpenAPI specifications to build a RESTful service property graph. And finally, Morist can use RPG to provide high-level guidance for coding sequence generation and refine the RPG with execution feedback. Thanks for listening. If you have any question, answer it.
Thank you very much, Yi. So this brings us to the end of the presentations. Now I'm going to open up the floor to questions. And I invite all the speakers and the co-authors, if they are present, to come back to the video chat if they are able to. And we're going to start taking questions. Yes, so we can take questions in the chat, obviously, as well. It's entirely up to you. If you have a question, either type it in or simply say that you have a question. I don't see anything yet in the chat. Okay, so we have the first question from Breno. Breno, do you want to ask this yourself?
Yes, I can do that.
Excellent. Please go ahead.
It's actually 2 questions for Tim. I was very interested in the solution you implemented using distributed tracing. I did some work in last years on coupling detection between microservices, also using distributed tracing. So there's kind of related work. My first question is, what kind of anti-patterns are you detecting? I saw you mentioned mega services, but what other anti-patterns are you detecting? And the other question is how you identify dependencies that between services that are using kind of messaging communication like async or pub/sub communication.
Yeah, thanks. So the first question, we identified 5 different anti-patterns, though we found there are more, but trying to describe an anti-pattern just with the vectors was not always possible. We had mega services which do too much work, then nano services which do not enough work, cyclic dependencies, bottleneck services, and services that do not like one specific task, but just like are mixed up. But we were not really able to detect that last anti-pattern because it was just too close to the mega service. So it was just like basically reporting the same services back. So those were the 5 that we were able to kind of describe. And the way we did the dependencies was basically through the annotations in the distributed tracing. So we were not able to detect all services because not all services actually reported to the distributed tracing, but most of them did. And if the sender, both in every trace, there was basically logged which service was calling which other service. And if we could identify basically that interaction between request and response, we just said, okay, these 2 services have a cause relationship and depend on each other.
Thank you very much. Breno, does that answer your question?
Yeah. I just think about the messaging stuff, like using queues like Apache Kafka or something like this, because you can have kind of transitional communication. Yeah? It's not point-to-point communication, and you may be lost in the chain of the communication between services. Because in distributed tracing, you know the origin and the destiny, but you don't know if it's actually a service. It can be a queue, for example, the destiny, and the services is just far on the way.
So I think this relates also to the abstraction level at which you're monitoring, and Tim knows the details, right? But I think I understand your question about whether you can detect dependencies that are linked to a publish subscribe or because those are particularly difficult to detect from the source code, right? Because they can be many to many. But the difference here is that we don't use the source code as input, but we use traces as input. And in traces, you actually can see, even though there might be a step in between, you might be able to see A goes to B via C pattern. Right? I don't think we have zoomed in on that, but I think in general, using dynamic data might actually be a way to find such implicit dependencies that cannot be easily detected in source code statically.
Yeah. Okay, thank you.
Excellent. So while we're waiting for any further questions that the audience or the speakers may have, I have a few. And the first one is directed at Petr, if he's here. So Petr, are you there?
Yes.
Excellent. Yes. So I was wondering about this notion of precision and recall that you're calculating. Was the deprecated code ever inspected manually for this, or where are these numbers coming from?
Right. So yes. So the precision and recall are not computed on the raw code. The code is converted into a tree, and then we
Okay.
compute precision and recall over 2 trees. There's other ways you can compute metrics, maybe even in the code directly. In fact, for our baseline, because it's not able to produce any trees, we just did simple token overlap. But token overlap is too loose of a metric because you can have them out of order and it doesn't capture compositionality.
Variations.
We also, in a follow-up study, we applied a neural machine translation model. And in that case, we are not able, in all cases, to convert to the trees because, NMTs are not restricted to, valid syntax. So you may not be able to always convert to the trees. But in our parser, in the case with our parser, this seemed to be like a native metric that incorporated the specifics of the task, right? That we're not just interested in getting many tokens right, but they also have to be put together in the correct structure. And that was motivation. I also know there's, even for trees, there's different metrics. For example, for abstract meaning representations, there's a metric called SMATCH, which decomposes a tree in a collection of triples and then looks for a triple overlap. But that would require us to convert the trees into AMR representation, which seemed like a redundant step. So we just instead settled on this subtree overlap.
Excellent. Thank you so much for the great answer.
Sure.
So are there any questions from the audience? I've got a few listed here. I can ask more, but I would like to give everybody an opportunity first. Okay. No takers?
I have a
Please.
question for Yoshi. Oh, wait. No, go ahead.
Oh, you go ahead. I'll wait.
Okay. Yeah. Is Yoshi on the call?
Yoshi, are you here? Have we lost Yoshi? Yeah, he might have left already. My apologies, Petr. He's not.
No, no worries.
So,
Oh, maybe is that
that's
no?
that's
That's
E.
fine.
Yes.
Okay.
So
Okay.
Tim,
Okay.
Tim,
Then
did you
I'll
have-
skip my question.
Sorry, Tim. Did you want to ask something?
Yeah, I still wanted to ask straight back at Bruno. So the BizDev, is that like a process basically that I can take away now into the company I'm currently working at, or how does that work exactly?
Actually, BizDev is not a process. It's just like DevOps. Yeah, you don't have a specific process, but you have ways of collaborating between business and development, like you have, for example, in development and operations. So, but the practices are actually a lot different because they are not technical. They are more social practices like meetings and clarification of requirements, prioritization, understanding of business value, and something like this. And the problem and the findings we got in this study are related to how people from development teams are actually contributing to business by performing activities that are naturally from business people. So they are actually proposing requirements, they are analyzing the business and try to get, for example, more success for the products, and they are analyzing business issues and try to propose the ideas, their ideas regarding features on how to implement some features to get better profit or something like this. And in this paper, we report that the organizational culture is the main driver for this kind of behavior, because in the case we analyzed it, the culture was kind of influencing people to do these things.
Yeah, okay. So, yeah, I don't know if anybody else wants more questions, but no.
I've got a question for Alex, if he's here. So Alex, you mentioned that the the coverage was initially very high before you even engaged in this project. Do you have any idea as to why this was the case? Was the structure of the code such that this was
yeah, let me clarify. So the coverage on certain core functionality like transaction verification was very high. And I think that the real reason for this is they put a lot of work into writing really good fuzz harnesses for part of the code. Now, there were other parts of the code that weren't as well covered, although as the paper elaborates, especially the full version, when I first came in, they were just not running enough fuzzing. Like the simple stupid message here actually is run your fuzzer a long time. Don't like think that like 1,000 iterations is anything in a fuzzing campaign. It'll only take a few seconds for some targets. But by the time I actually really got started on this during that summer, they had this on OSS fuzz and were, really pounding away at it with continuous fuzzing. And by then the coverage was very high for the good targets because they had refined those targets, I think, partly based on that feedback.
Mm-hmm.
So it was good because they put a lot of work into this. I mean, I think the fact in some ways that they asked me to do this is a sign of the fact that the project took fuzzing very seriously. It's not surprising. The biggest Bitcoin implementation is very concerned about, vulnerabilities and exploits. So.
Yeah, and that explains why they did such a good job to begin with. And
right, and wanted even more.
Parts, yeah.
And I think actually the biggest useful thing for them directly I did was actually just say run the fuzzing more. I think that would have eventually come out, but it probably happened a little sooner. Just saying, get this on OSS fuzz, whatever the barriers, get this running all the time. Don't limit it to small runs.
Excellent. Thank you so much.
Sure. So
if there are no other questions, I have one last one for Yi. Yi, are you there? You mentioned the number of baselines that you compared against, and I was also wondering about the subject systems that you did your testing on. What are these baselines, and where did you get the systems from? What are these systems that you actually tested?
Yes, so actually there is a research benchmark from EvoMaster. Yeah, they have maintained a benchmark of systems, RESTful system under test. And for the baseline, so we did this work about 1.5 years ago. So there are any limited RESTful API testing tools. So recently, one paper has been published on ISTA. So they have performed an empirical study about RESTful API testing. So they have compared about 11 tools about RESTful testing. And they have also released a collection of benchmark about 21 RESTful services. So yeah, it's very easy to follow their approach to develop your own solution. Yeah.
Excellent. Thank you so much. Okay, so last call for questions. It's almost time to wrap up. If there are any further questions for the speakers, please do not hesitate. No questions? Okay, so let me thank the authors and the presenters for the great work, and also the audience for being here. And I wish you a very nice day, evening, or morning. Take care. Bye-bye.
Thank you, Mike. Bye-bye.
Thank you. Bye.
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 Thank you. Bye-bye.